In number one, you have to change sine 32 to cos 58. Like I said yesterday, you don't have to show that step where you say 90 minus 32. You can just do that on the calculator and change it straight away. So it's positive cos 58. So your reference angle is 58, and you're going to work in the quadrants where cos is positive. Where cos, because you're looking at that one, where that one is positive. All right, so that's 1 and 4. Quadrant 1 is just the reference angle. Quadrant 4 is 360 minus. Now for this question, they said that we had to give x values between 0 and 360. Okay, so in this case, you only would have found suitable x values if you made n equal to 0. Okay, there were no other ones. Yeah. Okay, there were no other ones, so it was just 58 and 302. Any questions on number 1? 5 seconds. Okay. Well, number 4 is there at the bottom. You can mark 4 so long. 4 is a nice quick one because it was tan equals tan. The only thing that was a bit strange about 4 is that the reference angle was this complicated angle, 2x minus 25. But it's positive tan, so we work in the quadrants where tan is positive. But of course, we ignore the third quadrant there. For tan, we only have to work in the first. So you're going to say this angle x is equal to the reference angle, which is 2x minus 25, plus 180n because it's tan. Then you move that 2x over, it's going to become minus 2x. So x minus 2x is negative x. And now, guys, we haven't actually done an example like this before, but I hope you guys were fine. You just have to divide through by -1, right? Okay, so then you get x equals positive 25 minus 180n. And for that one, I think they just asked for the general solution. Any questions on 4? Okay, I'm moving slowly. There's number 8. So number 8 was finally one where we have a negative ratio there on the right, a negative number essentially. So we have to work in the quadrants where cos is negative, so 2 and 3. Your reference angle is still 42 degrees. So quadrant 2 is going to be 180 minus 42, and you get that. Quadrant 3 is 180 plus 42. And now again, we have to find specific values between negative 180 and 360. So I only found 3. Did anyone find more than 3? Was it just the 3? So I just made n equal to 0 in both of them. Then I got 138 and 222. If you made n equal to 1 here, and in that one, it would have given you values that are bigger than 360. So 1 didn't work. If you made n equal to -1 here, it would have given you a value that's smaller than negative 180. But it did work if you made n equal to -1 here. Then you got negative 138. How are we feeling about this work, guys? Just in general, it's going okay. Sure, normally Trig craziness. Okay. Well, today we're going to practice all the different types combined, so then we'll see. Okay, can I go on to number 9? I'll post these answers. Can I post them to classroom? You can copy it out of me. Okay, there we have number 9, guys. Number 9 was quite long because you had to change that sign to a cos. Now, I'm not sure if you guys were able to do that, but it's the same kind of concept, right? Let's just quickly go back to number 1. When we wanted to change sine 32 to a cos, we had to change it to cos of 90 minus 32. So 90 minus this angle, right? Now, this angle basically takes the place of the 32. All right, so if we change this sign to a cos, we're going to have to change it to cos of 90 minus the whole angle, the whole bracket. Okay, so just make sure that you have that there. So it's then 90 minus x plus 40. And then you would simplify that to 130 minus x. And then after that, it's similar to the example that we did yesterday, where you have cos equals cos. It's a positive cos here, so we work in the positive quadrants. Your reference angle is now 130 minus x. And then you would need to get your general solutions from there. Yeah. If I didn't simplify, I mean, I thought it was fine, but if I didn't simplify my reference angle in the beginning, it's fine. Would you, if I said 90 minus 50. Okay, then for this one, I got 5 values for x. Did anyone get more? Yes. I got negative 73, okay, so that is, oh, I forgot to go backwards with this one. Yes, sorry. So if you are doing 46.67 plus 180, no, it's 120, sorry, times -1, that one, there we go. Thank you. I forgot about that one. All right, so that is negative 73.33 degrees. And then that's it. Okay, so 6 values actually. Now guys, these ones where you have to change a sign to a cos or a cos to a sine, it can be the other way around as well. And you have to do like a 90 minus a whole bracket. These ones, as well as those trinomial ones, those are kind of the most difficult ones that you can get really. Okay, just in the sense that they're quite complicated. You have to do a lot of like in-between steps. But yeah, it won't really get worse than that in my experience. Are there any questions on number 9? Any specific step that you want me just to go through quickly? Yes?
So I did 90 minus 6 and then I did the x minus
90 minus 6.
You do the sine.
Yeah, but it's 90 minus that angle. So if that was just an x, you would say 99. Okay, so it's always 90 minus the original angle. Okay. All right, guys, you will be working on exercise 20 today. There are 14 questions. You might not get through all of them, but I want you to try and get through as many of them as possible. It's good to practice these trig equations all kind of mixed together so that you can identify what you have to do in each case. I will put the questions on the board just now, and then I'll just take a picture of these solutions quickly and I'll post them on Classroom for you. So exercise 20, it's on the same page as exercise 19. What's going on? No, you might, I said no, you might not get through all of them, but let's see how it goes. Number 7. Oh, did the whole thing. We'll see. We'll see. Just work at your own pace, guys. See how it goes. We'll chat again towards the end of the lesson. But please, you do need to get through as many of them as possible. All right, it's good practice. Please. The first, what is it? The first 7 are like kind of the basic ones. All right, so you don't have to change anything really. Then if you look at number 8, here you're going to have to change that sign to a cos. For this one, oh, what are we going to do here? It's a cos and a sine, there's no square. Because then I have a cos x or then I have an x and a 90 minus x, that's something else means. Wouldn't you like to with this outside? Yeah, and then see you guys kind of have the same idea. So if we move this cos x to that side, and then we apply sin x equals -13 cos x, and then compute the correction. That won't help us because then we have an x and a 90 minus x. Guys, look back at it or think back. I'm sure if I say this word, you're going to get it immediately. A little trick that I taught you. If you have just a sine and a cos and those squares, you're going to change it into tan. Okay, so that's what we're going to have to do for number 9. All right, so guys, I'm hoping that eventually you'll be able to see that immediately, right? You have a sine x, cos x. There's nothing that you can change really. You're gonna have to do a tan there. Here, what am I gonna do? Not really.
Oh, you take out this one.
I'm gonna have to factorize this. I'm gonna have to turn into a trinomial. That's gonna be a trinomial. That's a no calculator one. And then this is a difficult trinomial. You guys can figure that one out. And we probably won't get to 14, but we can chat about some of them. 161.
Wait, how do you know it's a no calculator?
No, I just mean that it's a cos equals cos, so you can say that that's the yeah. And also you can't really type that into a calculator.